I am Parkavi, Assistant Professor of Mathematics in Erode Engineering College. Now we see the subject vector calculus and complex variable, and the unit number is 1. The topic is differentiation of vectors. First we see the definition gradient. Gradient means the vector differential operator is denoted as delta. Delta is defined by I vector into dou by dou x plus j vector into dou by dou y plus k vector into dou by dou z. And also del pi is defined by I vector into dou by dou x plus j vector into dou by dou y plus k vector into dou by dou z into pi. First problem, if pi is equal to x, y, z, then find the value of del pi. So we know the formula del pi is equal to I into dou by dou x plus j into dou by dou y plus k vector into dou by dou z into pi values x, y, z. So multiply the pi value I vector into dou by dou x into x, y, z plus j vector into dou by dou y x, y, z plus k vector into dou by dou z x, y, z. So now we differentiate with respect to x. So I vector into y, z. Here differentiate with respect to y. So j vector into x, z plus k vector into x, y. So del pi is equal to y, z, I vector plus x, z, j vector plus x, y, k vector. And next problem is, if pi is equal to log of x square plus y square plus z square, then find the value of del pi. The same problem of first one. Del pi formula is I vector dou by dou x plus j vector into dou by dou y plus k vector into dou by dou z. And pi values log of x square plus y square plus z square. So multiply log of x square plus y square plus z square. I vector into dou by dou x into log of x square plus y square plus z square plus j vector into dou by dou y into log of x square plus y square plus z square plus k vector into dou by dou z into log of x square plus y square plus z square. Now differentiate with respect to x. So to differentiate log x means we get 1 by x. So I vector into 1 by x square plus y square plus z square. Again to differentiate x. So we get 2x. And then next one, j vector into 1 by x square plus y square plus z square. So differentiate with respect to y, we get 2y plus k vector into 1 by x square plus y square plus z square. Here to differentiate with respect to z. So to differentiate z square, we get 2z. So 2 by x square plus y square plus z square common in all the term. So x I vector plus y j vector plus z k vector. So x I vector plus y j vector plus z k vector is represented by r vector, x I vector, y j vector plus z k vector. And r square means x square plus y square plus z square. Here substitute 2 by x square plus y square plus z square value is r square. So 2 by r squared into xi vector plus yj vector plus kzk vector is r vector. So del pi is equal to 2 by r square into r vector. And the next problem, prove that del into r power n is equal to n into r power n minus 2 into r vector. So del into r power n. So use the summation formula I vector into dou by dou x into r power n to differentiate r power n with respect to x. So we get summation I vector into r power n, we get n into r power n minus 1. Again to differentiate r with respect to x. So dou r by dou x. We know dou r by dou x is equal to x by r. Here substitute. So summation I vector n into r power n minus 1 dou r by dou x values x by r. Here substitute. So summation I vector into n into r power n minus 2 into x. So n into r power n minus 2 is common. So xi vector plus yj vector plus zk vector. We know xi vector plus yj vector plus zk vector is r vector. So n into r power n minus 2 into r vector. That's all. Del into r power n. And the next definition is directional derivative. Directional derivative formula is directional derivative is equal to del pi dot a vector by modulus a vector. The problem is find the directional derivative of pi is equal to x squared yz plus 4xz squared at that point 1 comma minus 2 comma minus 1 in the direction of 2i vector minus j vector minus 2k vector. So here we have to find directional derivative. Pi value is also given. In the direction value is, that is, this is a vector. So here we have to find directional derivative is equal to del pi into a vector by modulus a vector. So first we have to find the value of del pi. Already we know the del pi formula, I vector into dou by dou x plus j vector into dou by dou y plus k vector into dou by dou z. This is del and pi value is given x squared yz plus 4x z squared. So multiply x squared yz plus 4x z squared in both the term. So I vector into dou by dou x into x squared yz plus 4x z squared, and then j vector into dou by dou y into x squared yz plus 4x z squared plus k vector into dou by dou z x squared plus yz plus 4x z squared. Here to differentiate with respect to x, to differentiate x squared, we get 2x, yz is common. Here to differentiate with respect to x means x is 1 plus 4z squared, and then plus j vector into, here to differentiate with respect to y, so y value is 1, so x squared z. Here no y variable, so this one is 0. And then next one, to differentiate with respect to z, to differentiate z we get 1, so x squared y plus, to differentiate z square means 2z, so 4 into 2 8, so 8x z. So this is del pi. At that point we have 1 comma minus 2 comma minus 1. This 1 value is x, y, z. Here we apply I vector into, to apply x value is 1 and minus 2 means minus 4. Minus 4 into minus 1 plus 4, and z square value is 1 plus 4 plus j vector into x squared is 1, so 1 the whole square into minus 1, so minus 1 plus 0 plus k vector into x square means 1 squared, y means minus 2, so here minus 2, z means minus 1, so minus 8. So 8 I vector minus j vector minus 10 k vector. This is del pi. And given point is a vector. A vector is equal to 2 I vector minus j vector minus 2 k vector. And the formula is modulus a vector. So modulus a vector means, modulus means square the coefficient. That means 2 square plus minus 1 the whole square plus minus 2 the whole square. That means square root of 4 plus 1 plus 4 is equal to root 9. So root 9 is equal to 3. So the formula is directional derivative is equal to del pi into a vector by modulus a vector. So del pi value is 8 I vector minus j vector minus 10 k vector into a vector value is 2 I vector minus j vector minus 2 k vector divided by 3. So here dot products means I vector dot I vector value is 1. So 8 into 2 16, minus 1 into minus 1 plus 1, 10 into 2 means 20. So by 3. So 36, 37 by 3. Therefore directional derivative is equal to 37 by 3. Next problem, find the directional derivative of 4x squared z plus xy squared z at 1 comma minus 1 comma 2 in the direction of 2i vector minus j vector plus 3k vector. So given pi is equal to 4x squared z plus xy squared z and the direction means a vector is equal to 2y vector minus j vector plus 3k vector. Here we have to find directional derivative. So directional derivative formula is del pi dot a vector by modulus a vector. So first we have to find the value of del pi. So same formula, I vector into dou by dou x plus j vector into dou by dou y plus k vector into dou by dou z and the pi value is 4x squared z plus xy squared z. So multiply the value in both the terms. So I vector into dou by dou x into 4x squared z plus xy squared z plus j vector into dou by dou y into 4x squared z plus xy squared z plus k vector into dou by dou z into 4x squared z plus xy squared z. So here to differentiate with respect to x, here x squared differentiate 2x. So 4 into 2 8 x z. Here x value is 1, so y squared z plus j vector into, here no y variable, so this term is 0 and to differentiate y square means we get 2xyz and the next term is k vector into, to differentiate with respect to z, so z is 1, so 4x squared plus xy square. Here to differentiate with respect to z means this value is also 1. So del pi at that point is del pi into 1 comma minus 1 comma 2. So here x value is 1, y value is minus 1 and z value is 2. Apply. So 4 into, here x value is 1, so 16 plus 2 plus j vector into, here minus 1, that means minus 4 plus k vector into, here 4, y value is minus 1, so minus 1 the whole square is plus 1, so plus 1. So 18i vector minus 4j vector plus 5k vector, this value is del pi and the direction is given, that means a vector is equal to 2i vector minus j vector plus 3k vector. So the formula is to find modulus of a vector. So take modulus. Modulus means square the coefficient. The first coefficient 2, so 2 squared plus and the second coefficient is minus 1 the whole square plus third coefficient is 3 square. So 2 square means 4 plus 1 plus 9. So square root of 14 modulus a vector is equal to. So the directional derivative is equal to del pi dot a vector by modulus a vector. So del pi values 18i vector minus 4j vector plus 5k vector into a vector means 2i vector minus j vector plus 3k vector whole thing divided by modulus a vector means square root of 14. So here I vector into I vector is 1. So 18 into 2 is 36. Then minus 4 into minus 1 is plus 4. And then 5 into 3 means 15 by square root of 14. So 40, 55 by square root of 14. Therefore the directional derivative is 55 by root 14. And the next definition is normal derivative. Normal derivative formula is modulus del pi. We already know del pi. And then only we take modulus only. Find the normal derivative of pi is equal to xy plus yz plus zx at that point minus 1 comma 1 comma 1. So we have to find the normal derivative. So normal derivative means modulus del pi. First we have to find del pi. Del pi formula is I vector into dou by dou x plus j vector into dou by dou y plus k vector into dou by dou z. into pi value is xy plus yz plus zx. So to multiply dou by dou x into xy plus yz plus zx plus j vector into dou by dou y into xy plus yz plus zx plus k vector into dou by dou z into xy plus yz plus zx. Here to differentiate with respect to x. So we get I vector into here y. Here no x variable, so this term is 0. Here one x variable. To differentiate x means we get 1. So plus y plus z plus j vector into here y variable is 1. So x plus z. And then next one is k vector into, to differentiate with respect to z means y plus x. So del pi at that point is minus 1 comma 1 comma 1. So here x value is minus 1, y value is 1, z value is 1. So apply y plus z means 1 plus 1. So 2i vector. Here minus 1 plus 1 is 0. 0 j vector. Here minus 1 also plus 1 is 0 k vector. So modulus del pi is equal to square root of 2 square means is equal to 4 is equal to 2. So modulus del pi is equal to 2. And the next problem is, what is the greatest rate of increase of pi is equal to x, y, z square at 1, 0, 3. That means what is the great rate means we find the determinant value. That is only the greatest rate. That means greatest rate means no negative value. So del pi is equal to I vector into dou by dou x plus j vector into dou by dou y plus k vector into dou by dou z into pi values x, y, z square. So multiply x, y, z square in all the terms. So dou by dou x into x, y, z square plus j vector into dou by dou y into x, y, z square plus k vector into dou by dou z into x, y, z square. So to differentiate with respect to x, we get I vector into y z square plus here we differentiate with respect to y, so we get x z square. K vector into here to differentiate with respect to z, so z square to differentiate 2x y z del pi at that point 1, 0, 3 x value is 1, y value is 0, z value is 3. Here one y value, so this one is 0. 0 into anything 0 plus j vector into x into z square. So 9 plus k vector into this value is 0, that because y value is 0. So anything into 0, 0 into anything 0. So 9 j vector. So have to find modulus del pi means square root of 9 square. We get 9. So the greatest rate of increases is 9. And the next topic is unit normal vector. Unit normal vector is defined by n cap. N cap is equal to del pi by modulus del pi. We already know about del pi and also modulus del pi. So here apply only. So del pi is equal to, here pi is equal to xy minus z square. At that point is 1, 1, minus 1. So del pi is equal to I vector into dou by dou x into xy minus z square. I apply directly. So dou by dou y into xy minus z square plus k vector into dou by dou z into xy minus z square. To differentiate x with respect to x means this value is 1. Here I vector into y. Here no x variable, so this term is 0. Plus j vector into, to differentiate with respect to y means y value is 1. So x minus 0. Plus k vector into dou by dou z, this value is 0. To differentiate z square means we get 2z. So y I vector plus x j vector minus 2z k vector. This is del pi. So del pi at that point is 1 comma 1 comma minus 1. So I vector plus j vector plus 2k vector. So modulus del pi is equal to 1 square. Here the coefficient is 1. Here also 1. Here 2 square. So that means root 6. So the unit normal vector means formula is n cap is equal to del pi by modulus del pi. Del pi values I vector plus j vector plus k vector by root 6. And the next problem is find the unit normal vector to the surface x square plus xy plus y square plus xyz at that point 1 comma minus 2 comma 1. Here the pi value is x square plus xy plus y square plus z square. So we have to find first modulus del pi means I apply directly I vector into dou by dou x into x square plus xy plus y square plus xyz plus j vector into dou by dou y into x square plus xy plus y square plus xyz plus k vector into dou by dou z into x square plus xy plus y square plus xyz. So to differentiate with respect to x, we get x square 2x plus y here plus yz plus j vector into here x plus 2y plus xz. Here k vector into this only xy. So del pi at that point 1 comma minus 2 comma 1. So I vector into x values 2 minus 2 minus 2 plus j vector into x values 1 and y values minus 2 upper then minus 4 x z then plus 1 plus k vector into xy. So minus 2. So I vector into minus 2 plus j vector into minus 2 plus k vector into minus 2. This is del pi. So then we have next we have to find modulus del pi means to square the coefficient minus 2 square plus minus 2 square plus minus 2 square. So 4 plus 4 plus 4 is equal to root 12. So unit normal vector formula is n cap is equal to del pi by modulus del pi. So del pi value is minus 2i vector minus 2j vector minus 2k vector and del pi values root 12. Here minus 2 is common in all the term. So take outside. So I vector plus j vector plus k vector by root 12. That's all. Thank you. We see the next topic. In this class, we have to discuss about divergence and curl. Divergence means divergence F factor is written as F1 I vector plus F2 j vector plus F3 k vector. And also curl F factor is defined by del cross F factor and it is written as I vector, j vector, k vector, dou by dou x, dou by dou y, dou by dou z, f1, f2, f3. The first problem, if f vector is equal to x squared I vector plus y squared j vector plus z squared k vector, then have to find del dot f vector and del cross f vector. Del dot f vector means divergent f vector and del cross f vector means curl f vector. First you have to find del dot f vector. Del dot f vector is defined by dou x into f1 plus dou by dou y into f2 plus dou by dou z into f3. And f1 means dou by dou x into fy is x square plus dou by dou y into f2 is y square plus dou by dou z into f3 value is z square. So to differentiate with respect to x means 2x I vector, j vector, k vector, 2x I vector plus 2y j vector plus 2z k vector. So 2 is common in all the terms, so take outside. So xi vector, yj vector plus zk vector. So del dot f vector is equal to 2 into xi vector plus yj vector plus zk vector. Then next one you have to find del cross f vector. So del cross f vector is written by I vector, j vector, k vector, dou by dou x, dou by dou y, dou by dou z. And then f1 vector is x square, f2 is y square, f3 is z square. So the matrix format, first you have to take I vector. I vector means this row and column is eliminated. So dou by dou y into z square minus dou by dou z into y square. Next we take minus j vector into this row and column is eliminated. So dou by dou x into z square, this one, minus dou by dou z into x square. And then next to take k vector, this row and column is eliminated. So dou by dou x into y square minus dou by dou y into x square. So to differentiate with respect to z means this one is 0 and this is also 0. So 0 minus 0 I vector minus j vector into, this is also here z square, this one is x. So to differentiate z square with respect to x means this one is 0 and this is also 0 plus k vector into, this is also 0 minus 0. So 0 I vector plus 0 j vector plus 0 k vector. So del cross f vector is equal to 0 I vector plus 0 j vector plus 0 k vector. And then next problem, if f vector is equal to x square minus y square plus 2xz into I vector plus xz minus xy plus yz into j vector plus z square plus x square into k vector, then we have to find del dot f vector, del into del dot f vector, del cross f vector, del dot del cross f vector, and also del cross f vector. And also the given point is 1 comma 1 comma 1, that means x value is 1, y value is 1, z value is 1. So first you have to find the value of del dot f vector. So del dot f vector means divergent f vector. So divergent f vector is dou by dou x into x square minus y square plus 2xz plus dou by dou y into f2. f2 means xz minus xy plus yz plus dou by dou z into f3. f3 means z square plus x square. So to differentiate with respect to x means this one is 2x, y value is 0, here only one x value. So to differentiate with respect to s means this value is 1, so plus 2z. And the next one is dou by dou y into with respect to y, this value is 0, this one is minus x, this is plus z. This one is I vector, j vector. Then next we have to differentiate with respect to z. So 2z k vector, del dot f vector. At that point is 1 comma 1 comma 1. So to apply x value is 1, y value is 1, z value is 1. So 2 plus 2, 4 I vector, and minus here minus 1 plus 1. So plus 0 j vector plus 2 k vector. So 4 I vector plus 2 k vector. Next we have to find del dot f vector, that means curl del dot f vector, del dot f vector. So dou by dou x into 4 plus dou by dou y into, there is no z value, so this one is 0, dou by dou z into 2. So to differentiate with respect to constant value is 0. So del dot f vector value is 0. Next you have to calculate del cross F factor. Del cross F factor means curl F factor. So I vector, j vector, k vector, dou by dou x, dou by dou y, dou by dou z, and f1, f2, f3. So f1 values x square minus y square plus 2xz, and f2 values xz minus xy plus yz, and then z values z square plus x square. So the matrix format. So first we have to take I vector. So this row and this column is eliminated. So dou by dou y into z square plus x square minus dou by dou z into xz minus xy plus yz. Next we have to take j vector. This is also dou by dou x into z square plus x square minus dou by dou z into x square minus y square plus 2xz. And next we have to take k vector. So this row, this column is eliminated. So dou by dou x into xz minus xy plus yz, and minus dou by dou y into x square minus y square plus 2xz. So first you have to differentiate with respect to y. This one is, there is no y value, so this value is 0, I vector into 0. And next you have to differentiate with respect to z. So here only one z value, so this value is 1, so minus of x. Here there is no z value, so this one is 0, this one is x plus y. And then next minus j vector into, here to differentiate with respect to x means x square, to differentiate x means 2x, and then minus dou by dou z into this value, this one is 0, this one is 0, and next one is minus 2z, and next plus k vector into, with respect to x, so z minus y, this one is 0, and minus dou by dou y, with respect to y means there is only one value, so minus into minus plus, so 2y. So x plus y I vector minus 2x minus 2z into j vector, this one is plus 2y minus y, y plus z into k vector. So given point is 1, 1, 1. So del cross f factor is equal to, so apply, the point is 1, 1, so 1 plus 1 is 2, so at that point 1, 1, 1, so 2 I vector, and the next one is 2 minus 2, this one is 0, so minus j plus 0 j vector, and the next one is 1 plus 1 is 2, so plus 2 k vector. So is equal to 2i vector plus 2k vector. So next one you have to find del dot del cross f factor. So del dot del cross f factor. So del dot del cross f factor is dou by dou x into f1 value. This one is, there is no this one. So dou by dou x into x plus y, and the next one plus dou by dou y into, here minus 2x plus 2y into z vector into z vector 1 plus dou by dou z into y plus z. So to differentiate with respect to x, so this one is 1, and next we differentiate with respect to y, so this one is 0 and 1 plus 2, and next one is differentiate with respect to z, so this one is 0 plus 1, so is equal to 4. Del dot del cross f factor is equal to 4. And next one you have to calculate del cross f factor. Del cross f factor. So del cross f factor means curl f factor, I vector, j vector, k vector, dou by dou x, dou by dou y, dou by dou z, f1, f2, f3. So f1 is x plus y, f2 is minus 2x plus 2z, and f3 value is y plus z. So I vector into, so this row, this column is eliminated, dou by dou y into y plus z minus dou by dou z into minus 2x plus 2z. And next one you have to take j vector. So this row, this column is eliminated. So dou by dou x into y plus z minus dou by dou z into x plus y plus k vector. This row, this column is eliminated. So dou by dou x into minus 2x plus 2z minus dou by dou y into x plus y. So differentiate with respect to y. This value is 1. So this one is 0. So I vector into 1. Here minus 2. And then minus j vector into, this one is 0. This is also 0. 0 minus 0. Plus k vector into minus 2. Minus y means minus 1. So minus I vector plus 0 j vector minus 3k vector. So del cross of vector values minus I vector plus 0 j vector minus 3k vector. And next problem, calculate the curl of the vector. So curl of the vector means del cross f vector. So del cross f vector is equal to I vector, j vector, k vector, dou by dou x, dou by dou y, dou by dou z, and f1 values x, y, f2 is y, z, f3 is zx. So same the matrix format, dou by dou y into zx minus dou by dou z into yz, and then minus j vector into dou by dou x into zx minus dou by dou z into xy, plus k vector into dou by dou x into yz minus dou by dou y into xy. So to differentiate with respect to y, there is no y value, so this one is 0. And next to differentiate with respect to z, so the z value is 1, so minus y, and then minus j vector into, here z, there is no z value, this one is 0, plus k vector into, there is no x value, so this one is 0, minus x. So minus y I vector minus z j vector minus x k vector. So del cross f vector is equal to minus y I vector minus z j vector minus x k vector. And then next we have, see the topic, irrotational and solenoidal. Solenoidal means the same divergent f factor, but divergent f factor is del cross f factor. Solenoidal means the condition is del dot f factor is equal to 0, and irrotational means del cross f factor is equal to 0. So first problem, if v vector is equal to x plus 3y into I vector plus y minus 2z into j vector plus x plus lambda z into k vector is solenoidal. So the given condition is v vector is solenoidal. That means del dot v vector is equal to 0. Then we have to find the value of lambda. So first we take the given condition. The v vector is solenoidal. So del dot v vector is equal to 0. So del dot v vector, that means dou by dou x into I vector plus dou by dou y into j vector plus dou by dou z into k vector into v vector. So given values x plus 3y into I vector plus y minus 2z into j vector plus x plus lambda z into k vector is equal to 0. So I vector, the unit vector value is 1. So dou by dou x into x plus 3y plus dou by dou y into y minus 2z plus dou by dou z into x plus lambda z equal to 0. So to differentiate with respect to s, this value is 1. There is no x value, so this value is 0, 1 plus 0. And the next one is, this value is 1 minus 0. And next one is 0 plus lambda equal to 0. So 1 plus lambda is equal to 0. So 2 plus lambda is equal to 0. So lambda is equal to minus 2. And next problem, find a value such that 3x minus 2y plus z into I vector plus 4x plus ay minus z into j vector plus x minus y plus 2z into k vector is solenoidal. The same condition, but we have to find the value of a vector. So it's solenoidal means the given vector is f vector. So del dot f vector is equal to 0. So dou by dou x into 3x minus 2y plus z plus dou by dou y into 4x plus ay minus z plus dou by dou z into x minus y plus 2z equal to 0. The same, to differentiate with respect to x, this value is 3. There is no x value, so this is 0. And next one is to differentiate with respect to y, this one is 0. Here only a value, this is also 0. And next to differentiate with respect to z, this one is 0 plus 2 is equal to 0. So 5 plus a is equal to 0 and a is equal to minus 5. Thank you. And next problem show that f vector is equal to yz I vector plus zx j vector plus xy k vector is irrotational. So irrotational means del dot del cross f vector is equal to 0. So del cross f vector is equal to 0. I vector, j vector, k vector, dou by dou x, dou by dou y, dou by dou z, f1 values yz, f2 values zx and f3 values xy. So I vector into dou by dou y into xy minus dou by dou z into zx and minus j vector, row column is eliminated, dou by dou x into xy minus dou by dou z into yz plus k vector into dou by dou x into zx minus dou by dou y into yz. So I vector into, so y value is 1, so x minus j vector into dou by dou x into xy, so y, here also y, plus k vector into z minus z. So x minus x is 0. So 0 I vector plus 0 j vector plus 0 k vector. So del cross f vector is equal to 0. So the given f vector is irrotational. And next problem, find the constant. That means we have to find the value of a comma b comma c. Show that f vector is equal to x plus 2y plus az into I vector plus bx minus 3y minus z into j vector plus 4x plus cy plus 2z into k vector is irrotational. So the given condition is the given f vector is irrotational. That means del cross f vector is equal to 0. We have to find the value of a, b and c. So del cross f vector is defined by I vector, j vector, k vector, dou by dou x, dou by dou y, dou by dou z into f1. That means x plus 2y plus az. and bx minus 3y minus z. 4x plus cy plus 2z equal to 0. So I vector into dou by dou y into 4x minus cy plus 2z minus dou by dou z into bx minus 3y minus z minus j vector into dou by dou x into 4x plus cy plus 2z minus dou by dou z into x plus 2y plus az plus k vector into dou by dou x into bx minus 3y minus z minus dou by dou y into x plus 2y plus az equal to 0. So I vector into, to differentiate y means this one is 0 minus c, that means 0 minus z plus 0, and this one is minus, to differentiate with respect to z, this one is 0, this one is 0, so minus into minus plus 1, and minus j vector into 4, here 4z means 4 minus a, and then plus k vector into b, here y value is 2, so minus 2 is equal to 0. So minus c I vector minus j vector into 4 minus a plus k vector into b minus 2. So 0 vector is written as 0 I vector plus 0 j vector plus 0 k vector. So equating I vector, j vector, k vector on both sides. So minus c is equal to 0. So c is equal to 0. Next, minus of 4 minus a is equal to 0. So minus 4 plus a is equal to 0. So a is equal to 4. And next, b minus 2 is equal to 0. So b is equal to 2. So the values a is equal to 4, b is equal to 2, c is equal to 0. Next problem, show that r power n into r vector is an irrotational vector for any value of n but is solenoidal only if n is equal to minus 3. That means r power n into r vector is irrotational. First you have to prove r power n f vector is equal to r power n into r vector is irrotational. So r vector is defined by x I vector plus y j vector plus z k vector. So f vector is equal to r power n into r vector means x into r power n into I vector plus y into r power n into j vector plus z into r power n into k vector. So first you have to prove r power n into r vector is irrotational. So r power n into r vector equal to, so irrotational means I vector, j vector, k vector, dou by dou x, dou by dou y, dou by dou z. First f1 values x power r power n, y power r power n, z into r power n. So commonly we have to take summation of I vector. That means we have to find only one vector. So I vector means dou by dou y into z r power n minus dou by dou z into y r power n. So summation I into dou by dou y into z r power n. To differentiate, to n into z into n into r power n minus 1 into dou r by dou y. Next, to differentiate n into r power n minus 1 into dou r by dou y. Dou r by dou y, here dou r by dou z. So summation I vector into z n into r power n minus 1, dou r by dou y is written by y by r, n into r power n minus 1 into z by r. So summation I vector zy n into r power n minus 1 into r inverse minus zy into n into r power n minus 1 into r inverse. So summation I vector zy into n into r, base is common, so adding, so n minus 2 minus zy into n into r power n minus 2. So plus zy minus zy n into r power n minus 2 is 0. So this one is I vector. So 0 I vector, 0 j vector plus 0 k vector. So r power n into r vector is 0. That means it's irrotational. And next we have to prove it's solenoidal only if n is equal to 3. That means we have to put n is equal to minus 3. The f factor value is solenoidal. So that means r power n into r vector is solenoidal. Solenoidal means summation I vector into the value is x into r power n. So commonly we take summation. So substitute all the terms, summation I vector into u v formula. First we have to apply u. U means x into v. To differentiate r power n into r power n minus 1. Again to differentiate r with respect to x. So dou r by dou x. So r power n into, to differentiate x with respect to x means this value is 1. So summation I vector into xn r power n minus 1 dou r by dou x values x by r minus r power n. So summation I vector into xn, that means x into x squared n into r power n minus 2 minus r power n. So summation I vector into I vector into, so we have to take x squared r power n minus 2 n into r power n minus 2 minus r power n, and next j vector into y squared n into r power n minus 2 minus r power n. So plus k vector into z squared n into r power n minus 2 minus r power n. So adding all the term, we take r power n plus r power n is equal to 3 r power n plus n into r power n minus 2 is common in all the terms. So take outside. So x squared into remaining term is x squared into I vector plus y squared into j vector plus z squared into k vector. So x squared into I vector plus y squared is r vector is defined by r squared. R squared is equal to x squared I vector plus y squared j vector plus z squared k vector. So 3 r power n plus n into r power n minus 2, this value is r squared. So 3 r power n plus r square is cancelled, so n into r power n. So r power n is common, so take outside, so 3 plus n. This one is r power n into r vector. So we have to put n is equal to minus 3. So we have to apply n is equal to minus 3. R power n into r vector is 0. So we have to put n is equal to minus 3. Then r power n into r vector is solenoidal. Thank you.